All right, everyone. Welcome to this week's episode of The Context. I'm Shannon Williams, one of the founders at Acorn Labs. I'm excited to have an incredible group of speakers with us today. Rodrigo Nader from LangFlow. We've got Henry Mao over at Smithery and Sundeep Gottipati joining us from MCP Defender. And I think we're gonna have an incredible time. This is our third episode of The Context. We've been running these ever since the MCP Developer Summit with a lot of great sessions that came in that we couldn't fit into the content of the day. So I'm really excited for these talks. This is the first time we've tried to do 3, so we're going to try really hard to keep things somewhat on time and try to keep it under an hour. But we'll certainly take your questions if people have questions as we go through the content. If you haven't seen them already, all the talks from the Developer Summit that we hosted back in May are live. There are amazing talks from the team at Anthropic, from Bloomberg, from Block, from Microsoft. So if you're interested in MCP and you're looking for the latest on what's happening with the protocol and what is being added, where the roadmap is going, please definitely take a look at some of those. Just a quick about, this is a weekly live stream that we host every week. We usually have 2 talks. Sometimes we have 3, like today, and next week we're also going to have 3. We've been trying to work to get people in over the next few weeks because we have so many people who are asking to participate. If you're interested in joining us, we welcome talks on anything related to MCP. So if you're using it, if you've built an incredible server, if you've incorporated it into a product you have on the market, if your organization is thinking about how to implement it as an enterprise, if you've built a cool MCP server, just by all means add it, and we'll certainly do our best to give people a platform to talk about what they're working on. So a little bit about how we run these. We try to keep the talks relatively quick. Our talks are really kept to 20 minutes or less. And as much as possible, we try to make a hard stop there around there. So it'll be right to the point. We try to demo as much as possible. I think today you're in luck. We've got 3 awesome demos planned. And after each talk, we'll be doing Q&A. If you're watching this on YouTube, you can certainly submit your questions there. Similarly, on Twitch, some of the other platforms like LinkedIn and X are a little bit harder to ask questions on. So if you want to get involved in the conversation, definitely join us over on YouTube on the MCP Dev Summit channel. And with that, let's get started. Today's talks, we're going to start with Henry's talk about tool calls, and he's going to talk about tool calls as the new clicks. Henry is the founder and CEO of Smithery. And with that, Henry, I'm going to turn the stage over to you.
All right. Thanks for having me. Okay, so a quick introduction. My name is Henry. I'm the founder of Smithery. I'm also part of the MCP steering committee as a member. And before Smithery, I was actually building my previous startup called Jenny AI. So today I want to give a high level overview of kind of the problem space within MCP because it's such a new space. I think there are more problems than solutions right now. And also a little bit of an origin story of perhaps like how I came about to MCP myself and Smithery. So to start off, at my last startup, Jenny, we built an AI academic assistant, and we helped around 1 million researchers write papers more efficiently and better. But there was one thing from my experience at Jenny that kept bothering me. So this was one student that showed me her AI workflow. It looks something like this. She had 7 windows open. She had ChatGPT on this one corner here. She had Semantic Scholar. She has Zotero for reference management. It was a complete mess. And she was copying and pasting between these different windows in order to achieve her automated workflow or AI-powered workflow. And when I saw this, I felt like this couldn't be the way we achieve, sort of autonomous agents that are practically useful, right? And honestly, this was a problem that wasn't unique to academics. Every knowledge worker out there is somewhat trapped in the same copy and paste hell, because while models are getting smarter, they're not really connected to the world. So if you remember the Arc AGI challenge, which I think went somewhat viral towards the end of last year, but is still ongoing. This is a challenge that's meant to challenge the IQ of an LLM, like how good it is at generalizing. And for a long time, this challenge has been sort of undefeated. At least the Arc AGI 1 version of the challenge. But at the end of last year, O3 came out, and at least the most expensive version of O3 was able to completely destroy this benchmark, or the first version of this benchmark. So it's very clear that models are getting smarter, right? They're continually getting smarter. They're beating these math benchmarks. But what we have, the problem we're facing, like today and also in the last couple of years, is that while models are getting smarter, we're not seeing a lot of AI agents in the wild that were being deployed. And that's what I like to call sort of Claude's paradox. It's on the one hand, we have all these models that are getting better and becoming stronger reasoners. But on the other hand, we don't have a lot of practically useful agents in the world. And the central problem with this is that intelligence has been somewhat disembodied. They're not connected with the real world. Now, before we kind of step into MCP, I want to kind of go over one common rebuttal against MCP, right? It's like, why don't we just use a computer use or operator, right? Because these kind of systems can expose a few sort of actions to the LLM, and the LLM can, in theory, do everything. Or why don't we just give the LLM access to a code interpreter? It could just write its own functions and do API calls, right? But I think the problem with this approach when applied to everything is that it's incredibly slow. And it's kind of like this picture here where you have a robot, you build a robot to like turn pages in a book. But what we really want is computers that can read the digital text, right? Which is a lot more efficient. So I think the computer use and these type of systems are great as a fallback for legacy system, and they're incredibly useful. But it can't be the dominant way AI agents interact with the real world. And I think more broadly, right? We have been kind of focused a lot on operator computer use, perhaps in the towards the end of last year and maybe earlier this year, right? I think this fixation perhaps neglects how the ecosystem will actually unfold. I think the ecosystem will be a co-evolution where we have, on the one hand, models are getting smarter. They're being able to use tools in a more human-like way. And on the other hand, we have AI native software emerging, right? Software becoming more AI compatible. And I think that's where MCP comes in. So I think by the end of last year, everyone from startups to major labs recognized the problem that we have models that are getting smarter, but they're not really like connected to the real world. Everyone from startups to major labs recognized this. And I think that kind of prompted Anthropic in late 2024 to introduce the MCP. Now, I won't go into details of MCP because this is the MCP summit, and a lot of people here are already familiar with MCP. But if you haven't heard of it, in one line, I would say it's an open standard where AI agents can talk to services using a common language. And when Anthropic released MCP last year, I was pretty excited. It's around November time. And that kind of prompted me into starting Smithery. The cool thing about MCP is that it's not just a traditional integration. I think like MCP kind of opens up a new category of software, which we like to call AI native services. And the difference between MCP and sort of a traditional software is that it's kind of designed from the ground up and made for AI agents. So yes, in theory, it is a subset of an API, right? But really, when people are building these services, they have agents as the customer in mind, right? As the user in mind. And so like you can't just like port an API into an MCP without a lot of thought. Yeah, so within months of MCP's launch, thousands of developers started building AI native services. At Smithery, we're seeing about 30 new deployments every single day. So agents now finally have a chance to access databases. They can browse the web, manipulate files, send emails, and do all sorts of different things thanks to MCPs. So now we have two ingredients solved, right? Models are getting smarter. Now we have a protocol that models can talk to everything else. So we're essentially done, right? AGI achieved. Well, I think not quite. There are a bunch more problems here that we had to figure out. So I think MCP really opened the sort of Cambrian explosion of AI native services, and we can now begin to build all these services designed for AI agents. But even with a protocol and models getting smarter, I think we still have a bunch of problems that we have to solve in this ecosystem. So first, if you are a person using, if you are a user of MCP, I would say you're probably facing what I like to call a quality roulette. So you have these lists of MCPs. It's pretty hard to find good quality MCPs. You don't know where to discover them. Probably you go before Smithery, you probably went on GitHub to try to look for a good MCP. Luckily, the MCP team, the committee, is working on an official registry to make this process a lot easier. But there's still an overall open question of how do we assign reputation and how do we determine if a service is high quality or not. And in addition to that, there's no way to really know if a particular service fits into your agent's needs. The next problem I want to highlight is that MCP has been pretty hard to install up until recently with Streamboy HTTP. You had this like 5-step process involving JSONs and involving pasting code almost, and this is probably not accessible to a lot of non-technical users. So packaging is definitely a problem with MCPs. And once you are able to get your MCP in a good package, you might just be faced with an unsecured MCP. So this is one MCP I found where in sort of the package JSON, there is a suspicious looking URL that's replacing a particular package that I installed. So while it's not a immediate threat, right, it could be a threat in the future if somebody swaps out this dependency as a poisoning attack. There's also the problem of authentication. Luckily, we have Aaron from Auth0 who presented in the main MCP summit in person, talking about this in a lot more detail. So MCP now has an official OAuth spec, but the problem still remains where if you have a lot of different MCPs, how do you manage all these keys, right? How do you manage the authentication for all of these different services? And lastly, I think this is perhaps a more speculative part of the MCP ecosystem or a specification. It's like, how do we get agents to pay for stuff on my behalf? So if we imagine like MCP as the main way for agents to talk to different services, they will probably have to transact on our behalf, right? So what would a future look like with a bunch of microtransactions? Okay, now I want to switch gears and talk about the developer side of the problem. So I've spoken about a lot of the different problems you might face if you are an MCP user. But if you're an MCP developer, there's a whole host of problems as well. So imagine you're developing an MCP, you're a service vendor. The first challenge you face is probably developer tooling. We have this official inspector from Anthropic, from MCP, which is not bad. It gives you basic like curl-like abilities to test out the endpoints of your MCP, but it doesn't really tell you like how an agent would use your MCP, which is really what you want to be testing, right? And so once you develop your MCP, right? Let's say you figured that part out. Now you got to deal with hosting, right? Thanks to Streamboy HTTP, it's been a lot easier to host MCPs compared to the previous SSE version of the protocol. But hosting is still a challenge because as a developer, you have to deal with stateful sessions. You have to consider resumability. There are a lot of quirks with shipping the MCP that is not really the same as a traditional REST API. Okay, so now you figured out hosting and you develop your MCP. So now you're ready to launch. And you launch your MCP. And 1 week later, what happens? Okay, you get 42 different tool calls on your MCP. So that's not bad, but now what? How do you kind of make your tool calls better, right? How do you make your MCP behave in a way where the agents would use it in its correct form, right? So those are open questions. And how do you distribute your MCP, right? How do you get your MCP out there? If you post it just on GitHub or Reddit, it's unlikely an agent would find your MCP. And once you do get your MCP used by agents, right? What's happening in production, right? There's no tooling right now to observe what's happening. And I want to highlight that for observability, I think one interesting thing is what we really want here is semantic observability, not just traditional kind of how many 200s, how many 400s and 500s you're getting, but like what are the agents using your MCP for, right? And I think all of this ties back into, in general, we want to try to create a good agent experience, because agent experience is a new user experience, right? We're no longer creating services for users, we're creating it for agents. And as an example of agent experience, I want to call out, I'm a big fan of Notion, but I will have to dunk on their MCP a little bit here, and I'm sure they will improve it. This MCP is looks like one where somebody took an open API spec and kind of translated it into MCP, right? And this is not the right way to like create a very high quality MCP for agents, because agents are going to read this and they will probably get confused. So we need much higher quality descriptions and higher sort of specification maturity when it comes to implementing MCPs. And we had to think about the agent experience in mind when developing them. Okay, so now you developed your MCP. You got so imagine you have like a great developer, great agent experience, right? Now you had to worry about monetization. So this is sort of the other side of the equation when it comes to payments, right? As a developer, like how do you receive payments for your MCP? Do you charge people subscriptions, right? Like traditional SaaS applications, or do you want to charge them by tool calls, right? So I think that's also an interesting open question. Okay, so in summary, I think we have a bunch of ecosystem problems. On the demand side, we have quality, we have installation, packaging, security, authentication, and payments. On the developer side, we have tooling issues, right? We have hosting issues. Distribution is also a challenge. Observability, is not really there yet, and monetization and payments in general are sort of an open question. So obviously, here's this is a good chance for me to give a plug for myself and Smithery. I'm here to tell you it doesn't have to be that way, right? So our mission here at Smithery is to orchestrate all these AI native services for AI agents and to solve and tackle a lot of these problems that are presented today. So far, as a pretty early startup, we've only scratched the surface of some of these problems I mentioned. But here's a little demo to showcase what you can build when some of these problems are solved. So what you're seeing here is the Smithery Playground, which is a new feature that we're releasing onto our website. The Smithery Playground is a place where, as a developer or someone exploring MCPs, we want you to be able to visualize how an agent uses your MCP and how it would call the tools there. So for the purpose of this demo, I'm going to show you a sort of workflow, a potential workflow you might want to build. So let me just submit this prompt here. So this agent is connected to Smithery, the registry, and it's able to access all the tools that are available and published on Smithery. So what I'm doing here is I'm asking the agent to do a complex set of tasks. First, it has to examine Notion, right? It has to read my Notion. It has to extract insights from some customer interviews I've been doing. So you can imagine a product manager needing to extract some insights about their users. Then I want this agent to go check my GitHub. And I wanted to look at the current issues. And then the third step is do some deep research on the web based on these things it has learned so far. And finally, I wanted to create a task on my linear based on what it has learned so far. So let me just run down what's happening here, because a lot of things are happening. This is sort of an attempt to do a bunch of different tasks in one shot. First, what you'll notice is that like this agent here is able to connect to a bunch of different MCPs because it can discover it through Smithery's registry. Once it connects to these MCPs, it's able to search for it, search for different things within the MCPs. It's able to read within the MCPs, and finally, it's able to take action on my behalf and create this linear ticket here. So it says, you can view or track the task here called synthesize customer interview insights. So, okay, let me go on my linear and see if I can, okay, I guess I need to sign in here, but okay, so I'm going to sign into my linear and let's see if I can find this. Okay, so we have this task here, synthesize customer interviews. So yeah, it has successfully created this issue on my linear. So that's about a short demo. It kind of just showcases what type of agent you can build if you're able to connect a bunch of different services together and have a good orchestration of these different services. So I'm going to go back to the slide. Okay. So before I wrap up sort of this demo and talk, I want to talk a little bit about what the prototype I just showed you is doing and how that leads to a potentially agentic future. So imagine an AI agent that has secure access to your email, calendar, documents, and so on. It's no longer trapped in a silo, right? It's embodied and is woven into a unified understanding of your life. When you go out and say, prepare me for the next week, it doesn't just list your meetings, right? Research does its research on attendees. It prepares briefing notes, right? It orders supplies for your trip and so on. Even drafts potential emails that you've been putting off. This is an agent that is able to kind of know everything you know and is able to do things on your behalf securely and accomplish your intents. But I think the interesting thing is once we have sort of the rails to run this agent, right? This agent won't just know you; it can learn from your experience, right? Every task you complete, every preference you observe, every recovery from failure that it makes could potentially make it smarter. And I think this is what Richard Sutton is alluding to in his paper, The Era of Experience, right? An era where AI agents can finally learn not just from the past era of human data, but from this upcoming era where it generates its own data and experience. So I kind of want to end on this slogan that we've been developing at Smithery, which is like, which I think, we're witnessing a fundamental shift in the internet's economy. One in which tool calls are becoming the new clicks. And in today's kind of landscape, we see a lot of AI apps. We have Harvey, Legal, Jasper, Marketing, and so on. As AI agents get more general, my bet is that like we're going to have vertical apps perhaps start to consolidate. And that doesn't mean there's no specialization anymore, right? There's still specialization. It's just that these specializations will kind of shift to the back end. We'll have thousands of AI native service apps powering broad agentic behavior. AI native services are becoming the default interface between a vendor and a user. So just as businesses had to go online in 2000s or go mobile in the 2010s, I think what we're going to see is AI native services becoming a dominant thing in the remaining 2020s. Thank you. Happy to take questions.
Henry, great job. Really interesting presentation. And thanks for sharing a little bit of sort of the journey you guys have been on. I had one question for you, which was about, you talked there about, the approach that someone like Notion has taken, where they've taken an open API and they've kind of mapped it to an MCP and published. And I mean, you guys probably more than anybody know how frequently that's the case, that the MCP, by the time you go to try to use it, is really, it's pretty far from an optimized service when you get to one. If that's the wrong approach, where should a developer go to figure out the right approach? Like who's guiding people towards the right approach? Is there one resource you would point to and say like, yes, read this, do this, because damn it, we can't just keep slapping MCPs in front of APIs and having crappy experiences for people consuming them.
So I think we're still pretty early in the ecosystem journey, right? So if, obviously like part of what we're doing at Smithery is trying to build out the developer tooling to help all these developers figure out how to create a high quality MCP. I think creating a high quality MCP is very much like prompt engineering, right? So it's not too different from prompt engineering, except you're doing tool engineering, right? You're trying to engineer tools so the agent can call it in the best way possible. So I think there's not a lot of dedicated resources today on building high quality MCPs, but I think the closest thing we have is a lot of resources on how to create good agents in general, and a lot of principles from creating good agents, like doing evals, right? Writing high quality evals and then running agents on these evals and then doing iterative improvements. I think those are principles that will transfer over to the MCP world.
Awesome. Well, maybe as you guys make progress on that area and you end up with a guide to building MCP things that don't suck, I would love to have you back to show that. But
Yeah,
otherwise,
awesome.
thank you so much, man. It was great, and really appreciate you taking the time to talk to everybody today.
Awesome. Thank you.
All right. Our next speaker is Sundeep Gottipati, who is the co-founder of MCP Defender. Sundeep is joining us from the He's going to talk about securing AI apps with MCP Defender. So, Sundeep, it's great to have you here today.
Thank you, Shannon.
Awesome. Take it.
Sweet. So I'm going to be talking today about securing AI apps with MCP Defender. So a quick background about myself. I've been a software engineer for about 10 years, and I've worked at small to really big companies. And over the last few months, my friend Saurabh and I have kind of really fallen in love with MCP. Henry's described it really well, but just to recap, it enables AI that finally does work for us through integrating through the tools that we already use. And we're still really early because developer awareness is high, but most non-technical people haven't heard of it at all. So what is MCP Defender? It's an open source desktop app that runs in the background, and it proxies and scans traffic between AI apps and MCP servers. So the four apps that we support today are Cursor, Visual Studio Code, Windsurf, and Claude. And right now we're available as a beta on Mac. You can download it on mcpdefender.com. We have Windows and Linux apps coming soon. And as I mentioned, we're open source, AGPL 3.0 license, so you can find us on GitHub. So why did we even build this? So as we did research into MCP, we realized the attack surface is really big. Just over the last few weeks, pretty much every week, there's a new published attack from a security company. And our goal with MCP Defender is to basically stay up to date with these attacks and ensure that our users are protected against the latest attacks. So most of the attacks that have been published so far are based around some form of prompt injection. So this also includes tool poisoning. If you've heard that term before, it's also another form of prompt injection. And the common theme here is there's no clear way for an LLM to tell what are instructions versus user data. So I'll give you a quick example here. This is the Cursor chat, and I'm asking Cursor to look at this GitHub issue, look at the crash log inside, and figure out how to fix it. But so this is the actual GitHub issue itself. It looks pretty innocuous. Users just reported that it's crashed. But buried deep inside this issue is a instruction for the LLM. So it's basically trying to steal my SSH private key and send it off to an attacker's server. So how does this protection actually work? So as I mentioned, it's a proxy. And so all of your traffic from all your apps on the left go through MCP Defender and talk to your services on the right. So I'll give you an example with GitHub. You make a call, with Cursor, you make a call to, let's say, fetch a GitHub issue. It goes to MCP Defender. MCP Defender then scans the request. If it looks good, sends it over to GitHub, which the GitHub MCP server executes it, sends back a response. And then optionally, MCP Defender can also scan the responses before returning the response back to Cursor. So the apps that we support today, they all have some sort of mcp.json configuration. And if you guys have seen this JSON file before, it's just a bunch of server entries. The way MCP Defender works is we rewrite these server entries to send the traffic to our proxy instead of directly to the server. And we also monitor these mcp.json files so that in case you add a new server or you edit one, we automatically detect the change and keep you protected. So I'll give you a quick example here. This is the GitHub MCP server, one of the entries in the JSON file, and the names at the top, then the command npx in this case, some arguments, and then the GitHub access token as an environment variable. So when you enable MCP Defender, this gets converted to this entry. Pretty similar, it's got the name up here with a lock and MCP Defender, just so you know that it's on. The original command is retained, but we instead pass it as an argument to this CLI.js script that we've written. And that's the thing that actually does the proxying. It sends the data to the proxy. So down here, you got the same GitHub access token and then some bookkeeping environment variables for MCP Defender, like which app is calling it and what the server it's calling. So what actually gets scanned by MCP Defender? We're scanning 4 different things. One, of course, is the actual request, so the exact data that would get sent to the server. but we're also injecting a few other things. So for example, tool metadata. This includes the name of the tool, description, parameter types, pretty much anything that is susceptible to prompt injection, we want to be able to scan. And then two other things is the user intent. So we include the user's original prompt and also the LLM intent. And we basically ask the LLM to include some reasoning of why it's actually calling this tool call. Both of these really add context and make it so that we reduce false positives on our scans. So as I mentioned, all that data is basically sent to an LLM with a bunch of signatures to check against. And if something's detected, it gets blocked. Otherwise, it's kind of invisible. You don't really think about it. You can scan with a free MCP Defender account, or you can use your own API keys for OpenAI or whatever you use. And soon you'll be able to use a custom LLM, so you can just point it at something remote or even local. So let me show you a quick demo of how this works. So this is MCP Defender. We got 3 tabs up here. The main tab is called Threats, and this is my threat graph or my traffic graph from the last few weeks. Down here is all the MCP tool calls I made along with their status. And the apps tab shows me like which apps I have installed, and it also mentions that it's protected, and also like it includes the servers that are configured for each app along with each tool for each server. So right now I have Cursor, Visual Studio Code, and Windsurf protected. The last tab is signatures, and this kind of gives you some very basic signature management. So these are all the signatures that get sent to the LLM and are checked. The data is checked against these signatures. Right now, you can just disable and enable them, but we're going to build some UX around this so you can add your own signatures and manage sets of signatures and things like that. And then finally, the settings page here is pretty straightforward. You got your account. If you want to use that, you can choose which model to actually scan it. So in this case, I'm using the MCP Defender account. Right now, we just have these 2 from OpenAI, but we're going to add some more. If you want to use these, all you have to do is just include your API key, and you can make those calls directly to those LLMs. And we also have, you can choose what things get scanned. So by default, just the request gets scanned, but you can choose whether to do both or one or the other. And then finally, we have this thing called MCP Secure Tools. If you guys have ever used Cursor, or even some of the other apps, they basically avoid MCP for certain things. So for example, if the app wants to call something on the command line or add a file, often it just does it itself with some built-in functionality. It doesn't call any MCP tool to do it. So what we do is we add a set of tools that do these things, and we instruct Cursor, for example, to always use our MCP tools instead of the built-in tools. And that way we can actually scan them. And yeah, down here is just the last bit of settings. You can, by default, it's on during login. So it's just, the whole point of it is to kind of run invisibly in the background, and you don't have to think about it until something bad happens. So I'll show you a quick demo of using this within Cursor. So I have 2 prompts here. One of them is, what are my Stripe products? So I have a Stripe MCP server configured. So we'll wait for Cursor here to make the MCP call. So the call is made, and then it starts spitting out some data. And then if I go back to MCP Defender in the Threats tab, I can actually see that Cursor is called the Stripe server with list products, and I can look at the details of which signatures got scanned, and clearly everything's allowed. The tool call was made. So now I'm going to show you how it looks if I make a call with something malicious. So this is similar to the one that I showed in the screenshot. Basically fix this crash log in this GitHub issue, and this GitHub issue contains some malicious instructions in the crash log. So we'll wait for Cursor to execute the MCP tool. And so you can see here, MCP Defender has blocked it. And it says, Cursor tried calling Git issue, and it was blocked because the GitHub issue contained malicious instructions for the LLM. And you get 30 seconds to allow or block. And by default, if you don't respond, it'll block. I'm going to go ahead and click block here. And then it shows up in the scan activity, just like the other one. You can see here again that these other signatures passed, but this one, it failed, and that's why it got blocked. So that's the demo. Let me head back to the slides here. So one question we get is, why protect an LLM with another LLM? Like, why can't these signatures just be added to the system prompt of Cursor, for example? That's a great question. So MCP Defender, what we really offer is a unified and customizable layer of security signatures that are complementary to any app-specific checks. And most apps don't even have any sort of security checks. Like Windsurf, I've noticed, does a little bit of checking here and there. But this MCP Defender just ensures that you're protected at some level, at a high level, across all of your apps. We're also adding deterministic signatures on top of the LLM-based ones. So one example is like detecting and blocking if a private key is being sent in a request, because that's usually a bad thing. And so what are we going to build in the future? So right now we only support STDIO MCP servers, but there's been a lot of buzz about remote MCP recently, both streaming and SSE. You can actually use remote right now with MCP Defender as long as you use the NPX MCP remote package, but we're going to natively support it soon. And we're also going to add support for more apps like Arc and Cloud Code. We're going to add custom and local LLM scanning, as I mentioned, and Windows and Linux apps as well. And finally, we're doing this project where we're implementing this research paper from Berkeley and FAIR called SecAlign. And they have some really promising results. So they basically said with using this method, we can actually reduce the success rates of various prompt injections to around 0%, which is pretty exciting. So we're working on that right now. And yeah, that's pretty much it. Thank you for your time. You can check us out on mcpdefender.com and also on our GitHub. Thank you.
Awesome. Sundeep, thanks so much for sharing all that. It sounds like you guys are making a lot of progress really fast. How big is the team?
It's just me and my friends, Rob.
Awesome. Sounds like, so did you guys start this year then? Just sort of beginning of this year?
Yeah, we started about 2 months ago, but we've been playing with MCP for a while now, since January.
Nice. Well, congratulations on moving so quickly. So the approach looks like it's all behavior-based, right? You're not doing any kind of scanning of MCPs or whitelisting, blacklisting of MCPs. This is all based on any MCP would benefit from MCP Defender because it's looking for behavioral attacks within the prompts and within the code, either going to the MCP or within the MCP itself, right? Did I understand that right?
Yes, that's correct.
Awesome. Really cool. Congratulations, man. It sounds like a really promising project and excited to see how it continues to develop. Thanks for joining us today.
Thanks, Shannon.
All right. Next up, we're going to have Rodrigo joining us. All right. Rodrigo is going to be talking about the projects that they're working on at LangFlow to bring MCP in. And it's been an exciting year at LangFlow. If you haven't followed, they were acquired a couple months ago by DataStax. Rodrigo, congratulations on that. I know you're joining us from Brazil. Thanks for taking the time. I'm sure you're busy right now with everything going on in through an acquisition. I've been through a couple myself. I know how crazy they are. So congratulations. How's it going?
Thank you. It's a pleasure to be here. It's going well. Let me share my screen and please let me know if I'm coming through okay.
Yeah, I as soon as you share your screen, I'll push it up there, but I don't see it there yet. Okay, you should be good to go.
Okay, very good. All right, so welcome everyone. It's nice to have everyone here. So presenting myself, my name is Rodrigo Nader. I'm one of the creators of LangFlow, and these past couple months, we've been introducing MCP capabilities into LangFlow in a very intense way. We've been investing in MCP very strongly. And I think with this presentation, I like to show a little bit of what we're doing with MCP, how we're doing it, and why exactly we're doing it. And hopefully we'll have time to go through a quick demo of how to use it in LangFlow and how that can improve your development cycle, okay? For those who never seen LangFlow before, LangFlow, the idea with LangFlow is that with LLMs and Gen AI apps, a new development paradigm was emerging, right? And the idea is that with traditional software development, what we do is we are coding and we find a problem in our function or we find a bug. For example, what we do is we look for the specific line of code that is causing that issue. And then we go there inside of that line, inside that function, and we debug that. We find the problem and we fix the problem, right? And with LLMs, the paradigm sort of shifted to a new way because the main function in your AI app is basically the LLM, is the model, right? So you basically have a black box that you cannot very closely control. You cannot access the inner states of a model and understand what's going on and change what's going on inside of that, right? So what shifted is that instead of developers spending more time inside of the function itself, developers started to spend more time on the inputs and try to tweak inputs, tweak the context, the sources that are coming through, and then try to see new results coming in the output. So LangFlow is sort of a tentative of a solution for that, a platform, a way to develop that is more visual, more interactive, and that gives you control to manipulate these LLM systems. Okay, LangFlow is a Python native platform. It is completely visual, and it gives you control to create LLM apps in different kinds of areas. So you can think of model chaining, reasoning. You can think of context assembling, RAG, agent orchestration, and so on. And it offers a series of components, pre-built components for you to play with, meaning components for data consumption, for RAG, for search tools, for text preprocessing, output structuring, guardrails, and so much more, right? But more than that, it offers the main suite of agentic capabilities, right? So we have the LangFlow agent, and we have a lot of other components that live with that agentic ecosystem, right? Together with features that help you create, prototype, understand, and interact with the systems that you are developing inside of the platform. And one of the things that we bet a lot inside of LangFlow is the capabilities, are the custom capabilities, right? So the idea that you shouldn't only be attached to the existing components that you create, that are already inbuilt in LangFlow, but you can also create your own components. So for example, you can literally code a component, decide what are going to be the inputs, the outputs of that component, and LangFlow offers an easy path for you to convert that component into an agentic component, meaning you can convert any component, even the ones that you create, into a tool, right? And then with that, you're gonna have not only an easy way to connect with agents, so let's say you created your own function, now you converted that function into a tool, but also have provide granular control or set exactly what are going to be the specific actions that your agent will have access to use, or what parameters the agent can use versus what parameters should be filled manually. Okay, but in the past two to three releases, LangFlow 1.3, LangFlow 1.4, we started to invest much more intensely into MCP, and I think that, so before I show what we're doing with MCP, and we're going to go through a live demo, I'd like to explain a little bit of the reasons why I think MCP made a big difference. Of course, risking over here stating the obvious of what everyone already knows. But I was myself very skeptical about why we need MCP for real, because right before it, we already have ways to provide tool calling, right? I've worked with frameworks like LangChain, like CrewAI, and all of those agentic frameworks. And you think, well, there's already a way for providing tool calling. We already have pretty good performance, pretty good accuracy, and these frameworks were improving. So why exactly do we needed something more than traditional API calling? And that is not just because it's becoming a standard, right? That was the argument that I think I needed to get into it very in depth. And I think it comes down to a couple of reasons, but the most important one to me is that MCP completely shifts the center of attention of how tools are exposed, right? In the first way, in the traditional way of tool calling, what you have is you hard code the rules and the tools into the information about the tools, right, into the agent prompt, meaning that the system prompt of an agent would carry all of that information as context, right, hard coded. And with MCP, what you introduce instead is you have the system that is going to be called. And this system itself is going to inform the agent what tools are available, what methods can be called, how they can be called, and so on. So the entire metadata surrounding the tool usage is not anymore part of the agent. It's now part of the tool set itself. Right. So this allowed for dynamic tool discovery. This allowed for a modular building. That's a clear separation between what is the responsibility of the agent versus what's the responsibility of the tools. And then the second big deal with MCP is sessions, right? So basically, an MCP call is stateful, meaning that in a sequence of calls, you're going to have a couple of advantages, which is models the agent remembering what was called in the previous what was stated in the previous call, right? So, for example, you're booking a flight. The first thing the agent is booking the travel, let's say the travel tickets, and in the second part, the agent is booking the hotels, right? From when the agent is doing the second part, the hotel booking, it already knows the dates for the travel, the dates for the flights. So it's much easier and much more accurate for multiple conversation calls, right? So with that, the idea was like, okay, how we're going to introduce MCP in LangFlow, and today we have it introduced in two different ways. LangFlow today can act both as an MCP client and as a server. So with the client way, you can use the MCP component to call external tools, right? Basically, we have a component exactly like any other component. It has the tool mode and the normal mode, and you're going to set up or configure or add one of the MCP servers that you're interested in, and you're going to call that from the component. And the other way that LangFlow integrates with MCP is by making projects becoming an MCP server. Right? So you can expose flows in your own LangFlow project as tools. So you can create a project, and each one of the flows that you create over there are going to behave as a tool. And then you can configure the parameters, you configure the description, so that you set so that you define how the clients like Cursor or Claude are going to call your MCP. So basically, what I'm going to do is I'm going to shift to a live demo, and let's try this out very quickly, just to show you how this works. So over here, we are, you're looking at LangFlow, okay? Each one of these projects is what can be converted into an MCP server, okay? And each project can have multiple flows. So let me start showing you one of these guys, and I'm gonna start with one of them that is actually calling the MCP component, right? In this case, over here, if you can see, I have the MCP connection component. It's attached to the MCP chart server, which I already pre-configured, right? So if I click over here, you're going to see that I have a couple of MCP servers pre-configured. And this has a couple of actions that I can even enter over here and disable if I want, right? So a couple of options that I can see. I can modify descriptions for the agent and so on. And what this is doing is I have an agent. The agent is calling this charts, and it's also calling the news search, which is not an MCP component. Okay, so the news search is a basic component in LangFlow that performs basic Google News search via RSS. So let's say I do something like Apple Inc. in the news search. What you're going to have as a result is a couple of URLs that are going to be retrieved. Okay, but now as I showed you in the slides, you have this tool mode button that can convert anything into a tool, right? So basically, the news search is working together with my chart MCP to power an agent that is going to perform some action to me. So this is something I've been playing with. I was doing Tesla. Let's try some stock options over here. So Apple Inc. retrieve Apple Inc. Let's say articles or news, right? News articles. Extract the sentiment and then create, I don't know, let's do something different, a pie chart, okay? Let's see how that goes. And this is live demo in a dev branch, so fingers crossed. Okay, so what you can see over here is that the agent first accessed the new search component, and then extracted a lot of news over here, and then it came and created the output visualization for us using these two tools, right? Cool. So basically, you have an agent, and you already can see how interesting or powerful can be this communication between MCP and non-MCP capabilities, right? Both from an agentic perspective, but you can also think of traditional workflows, because in some situations you want a part of your system to be agentic, but another part to be more rule-based, right? And this is an example where I have on non-MCP based tool, and another one that is highly relying on MCP. So this is one example. The other example that I'm going to show you over here is basically a sequential agent. This is what I call the quick research. It's similar to a deep research, but slightly faster and more shallow, right? And this is using a series of agents in sequence chained together to accomplish tasks, right? So we have a planner that is going to take the user query and split it and break it down. And then we have a researcher, which is an agent that has access to a web search. Third, we have the summarizer. Is going to take the web search results and access each one of the URLs, and then it's going to summarize the content. Then we have the retriever, the reviewer. Sorry, reviewer is going to just verify the information, make sure it writes some concerns to the writer, and then the writer is going to summarize the final article, right, for us. So this is similar to an OpenAI deep research, slightly faster and slightly obviously much simpler over here. I mean, in this case, I'm using the GPT Nano to try to make it faster for the presentation. So let's try to search for something. Let's, for example, say, what are the most famous types of coffee from Brazil, right? I don't know. Cool, and it started already to work. The first one broke it down into questions. Now there is the second agent over here is performing some searches. You can see the input it decided to use for each one of the queries, okay? And then it's probably going to generate something over here, and it's going to continue, right? So I'm going to wait a little bit because it's a sequence of agents, so it might take a while. But there you go. So main question, what are the most This is the reviewer agent. It's highlighting the gaps and new sub questions. And then I could and you could go crazy with this, right? You could loop and try to make this agentic system much more complex. But this is just a simple example. So the final report came along, and we have a couple of points that it extracted from the web and created this short summary of this short article for me about the coffee specialties in Brazil. So, but now the cool stuff over here is first, notice how it can be modular, right? And how atomic I can make this thing be for control. Because in the end, when we're thinking about agentic systems, we are also thinking about how much control we want to give to these systems, right? So over here in this case, I'm getting one output for each one of the agents, and I could break this down even further in multiple steps. Okay, but the nice thing is that, okay, I created that system, I create my sequence of steps, my agentic workflow, and I want to expose that now as an MCP server. So in our, hope you can see my screen, in our project specifications, we have the MCP server tab where each one of the flows that you saw, they can be accessed as MCP servers, all right? So if I edit the actions over here, I can even change their names, change their descriptions, so that an MCP client is going to call them. In this case over here, I'm going to add them to my cursor, right? So quickly integrate to cursor, and if I go to cursor over here right now, you will see that this is loading the tools that I just created, right? So I literally just created MCP servers using LangFlow. I assembled them together into one server. Each one of these tools can be accessed over here. And let's say in Cursor right now, I'm gonna say perform a quick research about, well, let's say the types of coffee in Brazil. Hopefully it's going to know, because of the prompt, it's going to know to use this tool over here, right? So quick research, yeah. So Cursor already identified that it needs to use our MCP tool, and there you go. Right? So what you're going to see over here is probably the same result that we saw over there, or something very similar. But you can immediately understand how LangFlow can not only become a tool for creating agents, creating RAG systems, and so on, but also become an MCP assembler tool, right? Or an MCP aggregator. You call systems, you pre-process or post-process the results of what you want. You maybe modify, add roles to them, chain processes together, and with very quick steps, you re-expose that as an MCP server. Okay, so this is the idea behind it. And just to show you a little bit, like if you open a new component from scratch, what you can do is in LangFlow you can literally code whatever you want over here, right? So let's say I'm gonna create a component that is going to count the number of chars in a input, right? So let's call it count chars, right? Very nice. I have a quick component that does something simple. It's going to count the number of chars in an input text, right? And that can also become a tool mode, right? So this is to me one of the most powerful features in LangFlow today, which is, hey, anything can become a tool, anything can be plugged into an agent, and now anything that is connected either to any flow or anything that is in a LangFlow project can become an MCP server, right? And this is almost unlimited power, because when you do something like this, you can already visualize how one flow can call another flow via MCP, right? So think of multi-agent orchestration, or hybrid flows that are going to use a little bit of MCP, a little bit of traditional workflow, and so on. Okay, so that's the idea with LangFlow. We also launched the LangFlow desktop, so it's becoming a cool way for you to explore and use our playground to test new stuff. We have pretty interesting tools for structuring information. So just in this final one, you can see, for example, an example where we are doing entity extraction, right? And the output, so news come in, we're extracting entities, exposing this as an MCP for an event extraction system, right? And there you go. So, well, let me come back to the presentation. So the idea of LangFlow is to make the life of whoever is creating AI systems in general, be it agentic, RAG, or anything that uses LLMs in general, easier and more powerful. We are obviously an evolving tool. Not only the ecosystem is evolving, but the platform is very new as well. So we welcome feedback at all times. Join us, join our Discord channel. We are over the moon with the amount of people giving us ideas, joining us, and helping us build what we're doing with LangFlow. So thank you very much.
Thank you, Rodrigo. Great demo, great conversation. So much, such an interesting way to think of, not just using LangFlow to consume MCPs, but LangFlow to actually build MCPs and build those MCPs that you can then consume through other agents or other workflows. Is that all functionality available today? Is that, you mentioned that some of the stuff was coming in the future. What's the current availability of what you were showing us?
I know this is available, right? Only a couple of details, a couple of wrinkles that you wouldn't see over there. Like, for example, the cursor plus button that we'll add in immediately, but we have everything already, right? LangFlow 1.4 was all about MCP. So if you download it right now, you're probably going to see a lot of that.
Awesome. All right. Well, thank you so much, Rodrigo. It was great having you today. Thank you all of our speakers for coming. Thank you everyone who joined us today. And we'll have all these videos split out as individual videos in the next day or two. So have a wonderful day, everybody. All right. Thanks, guys. Really appreciate you taking the time. Rodrigo, Sundeep, have an awesome afternoon. And hopefully we'll see you. We're actually working hard on the timing for the next Dev Summit, which is probably going to be in Europe in the fall. So the team from Anthropic and some of the steering committee have been kind of positioning time and dates and stuff like that. So we're, yeah, as we kind of put out for a call for papers and kind of announce it, certainly would welcome you guys to be involved. Anyway,
happy to join. Happy to join. So thanks for having us.
Congrats again on the. All right. Take care.
See you.
Bye-bye.